Miss Tejasri Kosbe, lecturer from Praveen Patil Polytechnic, Bhayandar. Today's topic is measurement of voltage and current, part 5, learning outcomes. In this video, you will learn about range extension of voltmeter by using multiplier, multi-range multiplier and universal multiplier, and advantages and disadvantages of multiplier. So first, necessity of range extension. So why we need to extend the range of voltmeter? So as voltmeter coil is thin and delicate and it can withstand for small voltages applied across it, so voltmeter cannot be used directly if high voltage is to be measured. So to measure high voltage, we have to extend the range of meter. Range extension of voltmeter by multiplier. So we can extend the range of voltmeter by using the multiplier resistance. A PMMC instrument can be used as voltmeter by just connecting a series resistance with the moving coil. This series resistance is called voltmeter multiplier. This combination of moving coil and multiplier is connected across the point whose voltage is to be measured. So PMMC instrument can be used as voltmeter by just connecting a series resistance with the coil, and this series resistance is called as multiplier resistance. So there are two main functions of voltmeter multiplier. First is it limits the current through the PMMC moving coil to a value less than full scale deflection current and thus prevents moving coil from being damaged. So first function is to limit the current through the coil, and second, it minimizes the flow of current through the voltmeter and thus do not alter the circuit current whose voltage is to be measured. Ideally, the resistance of voltmeter should be infinite. So the second function is to extend the range of meter by just minimizing the flow of current through the voltmeter. So second function is to extend the range and first function is to limit the current. So this is the derivation of multiplier. This is the diagram of basic voltmeter circuit. In this you can see there is a basic meter whose resistance is given by Rm and current flowing through this meter is given by Im, and which is connected in series with the resistor which is called as multiplier resistance, which is denoted by Rs, and this whole circuit is supplied through the supply voltage which is given by V. So let Im equal to Ifs is equal to full scale deflection current of meter, Rm equal to internal resistance of meter, Rs is equal to multiplier resistance, Vm equal to voltage across the moving coil, and V equal to full range voltage of meter. So first Vm equal to Im Rm. So by applying the basic law, V is equal to IR, that is Ohm's law, to this circuit, we can measure the voltage across the basic meter, that is V is equal to IR. So voltage across the basic meter is given by Vm. So Vm becomes Im into Rm. So Rm is the resistance of this meter and Im is the current flowing through this meter. So voltage across the meter is given by Vm is equal to Im into Rm. So this is the first equation, and V, that is the supply voltage V, is equal to Im in bracket Rm plus Rs. As this whole the supply voltage is in parallel with this basic meter and multiplier resistance, so we can write V is equal to Im into Rm plus Im into Rs. So when you put this Im common, we get the equation V is equal to Im in bracket Rm plus Rs. So as these two resistances are connected in series, we can add this and we will get the equation V is equal to Im in bracket Rm plus Rns. This is the second equation. So dividing equation 2 by 1, we get V upon Vm is equal to 1 plus Rs upon Rm. Thus, M is the multiplying factor which is given by 1 plus Rs upon Rm. So V upon Vm is the multiplying factor. So final equation becomes multiplying factor is equal to 1 plus Rs upon Rm. Next is construction of multiplier. The essential requirements of voltmeter multiplier to fulfill are: the resistance should not change with time. Change in the resistance with temperature should be small. So these are the basic requirements for the construction of multiplier, that their resistance should not vary or should remain constant. So for that purpose, the material which is used for multiplier is manganese and constant. Next is the multi-range voltmeter. So we get multi-range voltmeter by two methods. First method is using individual multiplier. So in this method, separate multiplier can be used for different ranges of voltage. The respective multiplier is selected by operating selective switch. So in this diagram you can see there are four multiplier resistances, that is Rm1, Rm2, Rm3 and Rm4. So we will get four ranges for this circuit, and we can get this range by selecting through the selective switch which is given in this diagram by S. So when we connect this switch S to Rm1, we get one range. When we connect this switch to Rm2, we get another range. So in this way we will get multi-range voltmeter. Next method is using universal multiplier. A single multiplier known as universal multiplier is shown. Tappings are provided on the multiplier. So in this diagram you can see there is a multiplier resistance which has tappings on it. So by selecting required tapping, we will get different ranges of the meter. And next is advantages of multiplier. So first advantage, simple method of extending range of instrument. So this is the simple method for range extension, and second is connection is simple. Disadvantages of multiplier. So first is power consumption increases as voltage increases. So power consumption is more for higher values of voltages. And second, construction of multiplier used for high voltages are costly and difficult. So the construction which is used to measure the high voltages are more costly as compared to low ranges of voltages. And third, measuring circuit is not actually isolated from power circuit. So this is the main advantage which is for shunt as well as for multiplier, that the measuring circuit is not actually isolated from power circuit. Measuring circuit means meter and power circuit means that is the voltage, or you can say supply. The supply is the power circuit and measuring circuit is the meter. So they are not isolated in this multiplier.